Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything I want to, science and math. Today we're doing physics, and we're talking about static electricity, and I talked generally about static electricity in the other video. And we're doing chapter 20 in Merrill Physics. It's an old book from 1995, but it's good. So it's cheap. That's why I picked it. And the physics hasn't changed, so it's fine. So anyway, we're going to talk through the math a little bit more. And the first thing is Coulomb's law. So what measures the unit for the amount of charge is called a Coulomb. And a Coulomb, you can read my handwriting here, is the charge on 6.25 times 10 to the 18th electrons. I used to, in my old physics class, show a video to the kids where they said, that's hard to imagine how much that is. But if those were grains of sand, it would cover the whole earth. So, deep. Like, I think they said like 6 feet deep, the whole earth would be covered in sand. So, 1 Coulomb is a tiny little amount of electrons, but electrons are so small that it's a bunch of them. So Coulomb figured this out. He got it named after him. Henry Cavendish had also done experiments, but he wasn't able to quantify it as much. So Coulomb got the unit. The Coulombs, not Cavendish's. And this is his formula that we're going to be using. I'll show you how to use it. And K is a constant 9 times 10 to the 9th power. So, and these old pocket labs is what I want you to be doing for your lab this week. All right, so let's look at a problem. Coulomb's law, 2 charges. Let's talk about what is Coulomb's law. I got all excited about it, didn't tell you what it is. It's the magnitude, remember that means strength, of the force that a tiny sphere with charge Q, Q is the symbol for charge, exerts on a second sphere with charge Q prime, so that's our Q's, separated by a distance d, which is squared, and that K is a constant, and it's what is the force. All right, so that's Coulomb's law. We're going to figure out this force. So example problem 1 on page 418. An object A has a positive charge of 6 times 10 to the negative 6 coulombs. Our object B, carrying a positive charge of 3 times 10 to the negative 6 coulombs, is 0.03 meters away. First, calculate the force. So we're going to use our equation, and we're going to just substitute everything in, and there's the answer. 1.8 times 10 to the second power, which is sort of stupid. I don't see any point in using scientific notation because people don't realize what that means. That's 180. See, I can imagine 180 newtons, but 1.8 times 10 to the second is just making it needlessly confusing. Now, I know that there is the thing about sig figs, and you might need to do it because of your teacher wanting sig figs, but normally I prefer real numbers that people can imagine. I found that most people don't understand numbers very well. Okay, and then our second question is, what would be the force be if the charge on B were negative? And it says, if the second charge were negative, the sign of the force would be negative in the opposite direction. So it would be the same, but it would just be negative there. All right, example problem 2. Coulomb's law, 3 charges. But what about if there's 3 charges? Okay. Object A has a 6 times 10 to the negative 6 charge, has 2 other charges nearby. Object B at negative 3 times 10 to the negative 6, and object C, which is 0.04 meters to the right. And it has a charge of positive 1.5 times 10 to the negative 6 coulombs, is 3 meters below. What is the net force on A? It says, solve the problem graphically. So they set it up in a vector diagram. This is A squared, that's B squared, and we can figure out C squared by using Pythagorean theorem. So choose a system with A as the origin, B is the positive x-axis, and C as on the negative y-axis. I said that backwards. So you see this figure. So that's our formula. We substituted everything in and get the force. And then force B is attractive toward B, the positive x direction. So that's force B. And now we fill it all in again for C. And now we can get the net. I like doing that using tangent. They didn't do that, but I did. We can use tangent is opposite over adjacent. Our 9 times 10 to the first, there's that needless scientific notation again, which is our opposite is our C force over adjacent, which is our B force, and we do that and then take the inverse tangent, and we can get the degrees is 42 degrees. So I like my way better on that one. All right, that's it. That's all the math. So not much there in that as far as math goes, not too hard. Just one little math formula, one math idea, and hope you thought it was fun. I did. Like, share, subscribe. Come back next time and we'll learn something else about electricity.